Okay, we have this problem and there are two guys standing in point A, and one is going to point C and one is going to point B, Greg and Brian. And we know that L and L are this sides of the triangle, so we can conclude that L squared 2 is this side of the triangle. That's kind of the quick part. The question is who gets there faster, and the two statements, they give you basically relations between the speed of them. So statement A will give you that, let me just get this pen. So obviously we know that the distance is L for Greg and L squared 2 for Brian. Let me get zoomer. We know that from the graph. And the statement A will tell you that the speed of Greg is 2/3 of the speed of Brian. So you get speed of Brian here and Brian's speed 2/3 is the speed of Greg. And literally you just compute what is going to be the time, which is the time is normally distance over speed. So the distance is L, the speed is 2/3 of speed of Brian, and from this one the distance is L squared 2 and is the speed of Brian. When you compare these two things, you basically end up, you cancel L and you cancel speed of Brian, and you end up comparing 2/3 with square root 2. So you don't really need to get to here. Once you can do all this, you know you're going to get to the answer because L gets cancelled and the speed gets cancelled. So the answer is not dependent on Greg or on L and speed of Greg or Brian or L on anything. So that's data sufficient basically. So that's good. On the other side, statement B is telling you that the speed of Greg, if you add 20, you get the speed of Brian basically. So they have different speeds, and now we have an addition here. That is the key thing. Because when you compute the same thing, it's L divided the speed or square root L divided the speed, and you want to compare these two things, you cannot compare them because you obviously going to cancel L because it's the same, so there's no point in comparing them, but you cannot cancel the speed of Greg with 20 plus the speed of Greg. And no matter what you do, you can move it up or down or do whatever, you're not going to be able to cancel. More importantly, if this would be an inequality, you cannot move it up or down because it's a variable that can be negative. In this case, it's not negative because it's a speed, so you would be able to move it. But in any case, you will never get rid of this plus sign. So this is the same that I normally explain on percent change. When you have a plus sign, it allows you to cancel less. When you have multiplications, like in this case, you will be canceling this with this, and then you will be cancelling this with this, and you can compare straight through 2/3 with square root 2. Okay, good.